Come on, YouTube, pick it up. There we go. So I managed to find it eventually. So this is what I was talking about. Zoom in a bit here. That's Alt. Speaking of. Alright, so a trade region is what I like. This thing that's highlighted here is a trade region. So in this case, we're saying that K is a type, that a planet in K is a system, there's a planet in K which is a type 1 system. So a type 1 system has one jump. Can trade with systems that are one jump away, or rather planets in systems that are one jump away. I think that's how I define them. That's not it. That's the first one. Yeah, type 1 is one jump. So that planet in K can trade with either E, L, pretty sure that's O or N, any planet in those systems, or a planet within its own system. This is a trade region. So I had to say, okay, well, we have our planets, we have our jump gates, so we have these connections formed now. So we have this kind of structure. Obviously, it's not similar to this. It's a lot more complicated than this, but we have systems that have multiple connections, and some systems that only have a few connections. And we need to figure out now. Okay, we need to be able to build the systems that planet can trade with as within its trade region. And that's what that last bit of code I was just showing a little earlier does. This bit here. So it says, okay, for each planetary system, get the gates currently for that system. Then for that system, get the planet. Get each specific planet this way. I did this way because when I tried to do it through a for loop on planet, it wasn't updating the system vector correctly for some reason. When I tried to update the planet, I did a for planet in planets, pls.planets. It wasn't updating correctly, even with a reference call like that. So I decided, okay, we'll do a for loop, and then I can just use we can update the planet specific planet object, and then use a new function in planetary system called update planet. Pass through that updated planet and the position that it is in the vector, and then update it that way, so it'll get saved properly, and then it started working. But we do that. We set up a trade region vector strings. This will be changing because I decided to make trade region an object now instead of a string vector in the planet. Get a temporary one that actually we don't need anymore. So I was operating with some different code before this, more simplified code. And then the target system. So the target system is again not used here, but it was originally the system that was a destination for the gate that we were currently looking at, but we're processing it differently now, using get connected gate system or connected systems instead of the other code. Although that is kind of the code that was there for each stage, with some extra stuff added in to handle various things like one-way gates and inactive gates. So this is another important thing, that is that you can't trade over an inactive gate. You definitely don't want to trade over a one-way gate, though I suppose you probably could trade over a one-way gate. The only problem is when you go there, you can't come back that way, so you'd end up taking a longer route around. So not logically, or at least algorithmically, that would never happen. The player could choose to do it that way, though, I suppose. I guess there are some situations where that might be beneficial, like maybe that's the only way you can get to a system that's not, in danger of your trade being like looted or something, but we'll get to that later. So we look at this is a little hard coded. This will be put into the settings when I fold this code into the universe proof of concept eventually. But so we're looking at this now. We have these settings here, and based on the type, we're saying, okay, this is the number of jumps that we have to consider for building a trade region with. So in the case of K, if we go back over to our thing here, that one planet in K that we're looking at here is a type 1 planet. If it was a type 0, then it would only be able to trade with other planets within K, because type 0 planets cannot trade outside of its current system. Now let's look at, was it A? So there's a system over in A. So 1, 2, 3, 4. So there's a type 3 system, I think. Or type 3 planet that we're looking at in that system. 4 jumps, type 3, yeah. So we have a type 3 planet in this system, and we have to be able to handle 3 jumps. Now, that's a lot longer, a lot more of a distance. So, actually, it might be more than that. 1, 2, 3, 4. So we got 4 here. 1, 2, 3. Oh, I guess it is 4. Never mind. It's a... Yeah, no, it was 4. I did say 4. This confused me. So any system within 4 jumps, even if it's only 3 jumps, like N over here, is part of the trade region. So it's kind of what I wanted to do with it, was say, okay, the higher the type of planet, the class of planet, the more trading power it has. So that part's been completed, and now what I'm working on is building the actual functional trade region that can actually be used and processed and actually be thrown into some sort of economic processing. Originally, the idea was to say, okay, we'll store a string of the systems that this planet in this system can trade with, and then from that we'll actually build out a trade region in code. And I was starting to think about it, and I thought, that's going to be really intensive, because you just have these strings. You have to actually do all the work to connect everything together, and then do all the processing to determine which route, which planet to trade with, and which route's going to be the best route, and so on and so forth. Note that if you go that, also note that you can't go like 1, 2, 3, 4, 5. That is an interesting concept that I just thought of. So what if we want to get to, I think this is C? I think that's C. Whoops. Yeah, so if we want to get to C, you can't go more than 4 jumps. So that's kind of interesting, interesting thing. But like, there's more than one way to get to L. You can go this way or this way. P, there's only really one way to get to there. For K, you can go 1, 2, 3, 4, or 1, 2. Now, as for why you might want to do the 4 instead of the 2, well, let's say that this particular trade line here, let's say that this trade lane, let's say that there are a lot of high-level, high-type, high-class planets here that are doing a lot of trading with K. And that K is sort of a lower security level system. Let's say it's maybe a 0.7 or a 0.6 security rating, whereas E is like a 0.8, we'll say. However, in E, we also, since it's a bigger system, we also have a more prosperous system. We have a lot more piracy in it. And let's say that over this trade line, there's been maybe 25% of all the trades that have gone over this trade line in the past however much period of time you want to use turn or actual time in the real-time version of the game, has been basically looted by pirates. You might want to say, okay, well, it is shorter, but at the same time, there's a 1 in 4 chance that my shipment's gonna get stolen. So maybe we'll take the longer route because it's safer. So that's kind of some of the sausage, if you will, that's going to go into the making of the economic engine, which is, routes are not going to be just static. They're going to be various things about them. There's going to be how lucrative they are. So if you take a shipment across this trade route versus this trade route, it's going to probably cost more and return less because you are taking a longer route. And maybe these trade lanes are not as profitable as this one is. However, there's a much larger chance of getting your shipment totally, completely just ransacked, and so you won't have as much cargo being traded with K. And all that's going to kind of go into the making of it. So that's kind of where I just decided, was thinking and saying, okay, so if we're doing this by strings, how the hell are we going to do this effectively and performance efficient? And I said, okay, really, there's no way to do it that way. We have to say we have this object that's going to be called trade region. Trade region will be broken down into trade routes. Well, lanes. I think it's lanes and routes. Or is it routes and lanes? Routes, then lanes. Yeah, okay. So the routes are going to be, okay, we're going to calculate out the top 10 trades that need to happen based on supply and demand. So this is the other thing that's going to get kind of annoying later on, is how am I going to do the supply and demand part of it? Because I'll have to build out some sort of, first I'll have to build out the rest of the code to generate the size, the population, and all that kind of stuff, and the various planet statistics into this, some of which exist in the other code, some of which don't exist in any code yet. So I'll have to put the existing code for some of that into the proof of concept economy code. Then on top of that, build in new functionality to do resource generation based on just some randomly assigned things, like this planet will get a random number of factories and mines and farms and cities and water generation stuff based on its size and its population. And then based on that, we'll have this amount of resources generated over a turn. And then from that, we can build a supply and demand list. So like, let's say that there's a lot of population but not much food generation because there's not a lot of arable land or something on this planet. So food is going to be a high demand item, low supply item. So that's going to be one of the items that'll be falling into a list of trades that the planet will do with another planet within its trade region. So I have to figure out how to build all that to first be able to generate resource generation and consumption based on the population, based on the stuff that's creating the resources, and then how the population consumes the resources. Then based on that, I can then say, okay, now that we have this, we can build our supply demand list, and then we have to look at other planets within the trade region and say, okay, first of all, what planets are willing to trade food for something? Next, what do we have that we can trade with that planet for their food? Third, which planet is the closest? Or which planets are closer? So the closer planets, we'll sort it. I'll probably sort like a list or something based on their proximity to the system that the planet's in. Then how much food how do we maximize the food that we can get with what we're gonna trade with for the food? So then we'll go through that sorted list and say, okay, which of these planets offer, maybe the top 5 planets offer, or however much percent of that list, maybe we'll say top 25% or something of the list, have the best trades available. Next, we say, okay, of those planets now, look at the trade routes to those planets. So for the trade route, we're going to look at all we're going to look at the trade path vector here, which has the trade lanes in it, this thing here. And we're going to say, okay, comparing these two together, which route to this planet to this first planet, we'll say there's 2 planets that's considering now at this point. Which of the routes to this planet that are possible give us the most food but have the lowest risk of being raided, or have the lowest risk? So risk is not the same as the raid chance. It's a different thing. Risk is the amount of piracy last reported in that between those 2 systems. So between one system and another system, the total number of pirates or piracy in those 2 systems combined is what will be measured in the risk. Raid chance is based on that risk. What's the chance that this cargo with this value is going to be raided on that trade route, on that particular route? And then it'll say, okay, so for the most output, for the lowest risk and lowest chance of being raided, this is the path we're going to take to that planet. Next, I'll look at the other planet, do the same calculations, and then say, okay, based on these two optimal paths to these two planets, which planet do we want to trade with? Obviously, it'll go with the one where it's the least risk for the most return. And then that trade will happen. The planet will get its food. The other planet will get whatever it's trading for the food. And then what will happen is that the shipment will go to that planet, and then the shipment will come back from the other planet. So let's say they're trading lithium or something for it. So the lithium goes out to that planet. That planet then sends the food back to the trade initiating planet. And then in between there, at any point along the way, there can be raids that'll happen that'll either completely wipe out the shipment or reduce it a bit, or somehow delay it or cost, things will happen and it'll cause other things to happen. And so eventually that planet will get the food. And depending on all the various other outputs, maybe it doesn't get all the food it wanted. So then there's like a population die-off. Okay, so population goes down. Food is no longer that big of a deal. Maybe now resources to build cities is now more needed because there's a population boom from that food demand becoming a oversupply. And so now they'll go out and do other trades for those resources, and then eventually, it'll just kind of go back and forth between those kinds of things. And all that together will make the different trade routes, trade paths, trade lanes have particular economic values, and you'll be able to see all that. It's an interesting idea. It's a very complicated piece of business that I'm trying to work out. And I've just been trying to piece this thing together as best as I can to try and get something that works a little bit for the developer's vlog. Let me see. I think this may or may not be buildable. I think it's buildable right now. I don't think I've done anything to actually connect the new code in yet, so I could be wrong. There could be stuff missing that I don't have yet. I just want to go ahead and run this and show you what it does. If it'll build. Looks like there's going to be some errors. Wow. We got trade lane. Okay, so trade lane H and CPP has got stuff that is not really working very well. Trade lane dot H. Is that even? Well, it has to be open. Yeah. So trade. Right, I was going to create an actual object that will have the trade, that'll have like the stuff that's being traded, what process the trade is in, if it's on the outgoing or in the coming back, what's on what's in the ship or ships that are doing the trade convoy, what it's worth, and all the other things that we'll use to determine whether or not pirates will have an increased chance of maybe wanting to try to raid it or something. So if I take that out, I think that's all related to that one line of code generated 19 errors. That's how ridiculous it kind of gets in IntelliSense. Maybe, we'll see. But I don't think it was all related to that one. Yeah. So right now we have this code in here right now that's basically just allowing you to examine systems and make sure everything is actually being generated correctly. So I've decided to make 20. I've made 30 systems, but did I limit to 25 or did I say 25 is the minimum, 30 is the maximum. And there's 25 system names I've just created, some just basic sys1, sys2, sys3, etc. to sys30. We are using a three-dimensional system for system placements, using the Pythagorean theorem to calculate the distance between systems to determine if the systems are close enough or if they are too far away to, and they will fall outside of the range that I put of 155 astral units to make the gate connections. So I'm positing that there's going to be a theoretical limit at which gates can no longer connect to each other. And that's what this limit will be. I'm not sure if I'll make that a changeable value in the settings, because that might be something that's lore related. So that might be just something that's what it is and that's what's going to stay. The problem with that is balance, because even with 155, I'm running into situations where we have systems that have no gates in them, which is not something you don't want. You have a system with no gate in it at all, period, no way to get to it, then you're kind of screwed, because there's no way to get to it. So just sitting there doing something, and you can't even get to it in the game. But I'm going to put in a system number, let's say 10. Let's take a look at system 10. So system 10 is system 22. The security rating for the system is 0.57. Its positional location is negative 79, negative 97, negative 90, negative 46. It has 3 planets, 2 jump gates. So all the planets are pretty small. Type 1 and 2 type 2s. And we have an inactive gate and a one-way gate. So this is a system, like I was mentioning, where, and this is fine for maybe a system that's being generated on the second or third expansion of the universe, but on the initial systems, you don't want to have something like this. So let's choose a different system. Let's go with 18. So we have one active gate. However, that's the only connection it has to. So it's a type 1 planet, so it only has one jump. So it has a very small trade region, so only system 23. Let's try 5. Okay, here we go. Something a little more reasonable here. So this is a very high security system, so 0.95. Has one gate to system 20 that's active. However, we have a type 2 and a type 3 planet here, so we have multiple jumps. And here you can kind of see how this works between them. So this type 3 planet has more systems, similar systems to this, but more systems in its trade region, because it can reach a larger area than this one. But you still see 14, 20, 30, 7, and 8 in it. This one also, though, has 16, 28, and 8. Or no, 9. So it has a couple more systems in it that I can trade with. So now the problem is now taking this string-based trade region and actually turning it into an object, populating all that stuff, and then processing it, and doing all the stuff we were just talking about. It's going to be a really complex system, and I don't think I'll be able to get it done for the developer's vlog the way that I want it to, like I explained it. What I might do is say, okay, I'll just create some random, some variables that'll store like a consumption value. Every turn it'll consume this many resources. And it may just have one resource, maybe be, so have Zarn obviously for trading with, and then have another resource to have to trade for. And then we'll just have every system have that resource. Some systems will generate it more than others. Some systems will consume it more than others, and that'll form the basis of a basic economic system that we can then flesh out more completely for the whole thing I was explaining earlier. I guess I'll also show you the mod tool. This is pretty. I think this is. I'm not going to probably be doing any more work on it than I have already done. Load it up here. So this is built in C#. Blah blah blah. Let's see. Is this the one? Review tool. Oh yeah, no, it's this one. Yeah, 2017. So if you remember a while ago, I started working on a mod tool that was based on some. Well, I had a bunch of code in it for editing INI files to handle the INI file that we're using, because at that time I was using boost options, which is an INI kind of parser for C++ in the boost library. Decided to stop using boost because it was annoying and it wouldn't compile properly anymore for the later versions of Visual Studio that I wanted to use it on. So I decided to get rid of it and just put everything in the database to make it easier that way to handle. And that kind of made this easier too. So I've kind of showed this before. I'm going to show it again now. Let's go and run it. So it's actually pretty complete right now. The only thing that's missing is like the future casting stuff, which I'll talk about once we get to those features. So version 1 of it, key features, direct editing of the database, query-based searches so you can find what you're looking for. Future casting lets you know what, if any, effects your changes will have in the game without having to actually load the game and run it for a while. Quick creation of bulk, insert, or update queries. And mod using as little SQLite or as not as possible or none at all. So this is like aimed at making modding this game really easy and simple and making it so you don't have to have like a SQLite administration tool and know how to use SQL to create new records or update records or change things. So it's pretty simple. You have 4 tabs here that correspond to different types of features. The query browser just allows you to see information. The advanced query browser allows you to do more complex queries like doing joins. Specifically, it's for joins. So like, let's say that you want to build a, you're adding a new weaponry and new ammunition. You want to tie the ammunition to the weaponry. You can run a join check or join query here to see if the cross-reference tables you're using are properly set up or not, and if the game will properly read it or not. Database editor, so this is for editing the database, either creating new records or editing existing ones. And then future cast is something that hasn't been worked on yet. Basically, it'll say, okay, once you made all your changes and you want to see, let's say you made a change to the base experience that destroying enemies gives you. And you want to see that if your change to that has either made the difficulty too hard or too easy by making so that you give too much EXP for that, CXP for that, or not enough. That's what this will do. It'll have a chart or a graph here that'll kind of chart the EXP curve. If you're dealing with the player, changing stuff for the player, EXP growth formulas, formula bits, or if you're using changing stuff for enemies, it'll show you how much experience various types of and levels of enemies of that type that you're looking at will give you. I guess I can load it up and show you kind of sort of what it'll look like actually. Where's Excel? Damn it, don't close on me. Fences is sometimes very laggy. Not sure why. So, is this it? That's curved charts. It's not, maybe you want the other one. EXP calcs. It's documents. Here we go, yeah. So this is kind of what it'll look like. You'll pick so let's say you're changing the space value to something. This is another kind of tool you can use, this sheet. So like, for example, there's the Hellfang Raider. Let me change the base experience to, so this is based off of this. So let's change this to, let's say you want to change it to 78. Alright, and then it'll kind of update everything and show you the new curve for it by level. And it'll show you the CXP reward for killing that enemy per level as well. Let's say you want to do something a little bit more different. Let's say you want to change the factor for Hellfang Raider from 1.45 to 1.52. And it'll show you, that update. But then you want to make this, say, so 78, make it 45. And so this is kind of update in real time and show you exactly how the curves look and what the endpoints are and whatnot. That's kind of what you'll see in the futurecast part. You can either tell it to use what's in the database or choose an option to supply an option or supply a value that you would then maybe be testing or checking to see what it would do before you add it into the database. And it'll do the same kind of stuff. And this is something else I was working on that I didn't really think get too complete. So let's actually go ahead and do a few things here. First of all, we're going to load the database. We have when we load the database, then we'll have some, let me see, is there preferences? Okay, we haven't added that in yet. because in the preferences you'll be able to specify the database you want to use and the location for save files. Save file editing has not been done yet though. This is only for the main database so far. So once you load a database, you'll get a list of the tables in that database, and whatever table you select, you'll see the field list over here, so you can use that to refer to when you're building up your conditions and what fields you want to see in the query. So let's say we're going to look at, let's go with, let's go with ships, I guess. So the field list, we'll do ID. Let's also do name, class, subclass, CPU, RAM, and we'll also do total slots. And cargo, as well as X cost. And we won't do any wear conditions. So we just want to have this kind of stuff. So we'll pull up all the information for the ships now. So since we have no wear conditions, it's going to do everything. Which is fine. There's a lot of records in here. So now let's say, okay, we got all these nulls that are kind of polluting the data. So we're going to say where name is not equal null. So we don't want any null named ships. We just want the ships that exist and that actually are in the database that exist with data. So here we have our data here that we wanted. So we got all the ships that are in the database right now. Now let's say, okay, I only want ships, so we'll add an and here. I only want ships that cost below 50,000. So where X cost is less than 50,000. And then I want to order it by the X cost as well. So order by X cost descending. So now we have our ships in descending order that it costs less than 50,000 Zarn. Let's actually make it less than or equal to. Okay, so there are no ships that are 50,000. Okay. So now let's say, okay, let's only look at ships that are of a particular type. So X cost and class N. So only battle cruisers, destroyers, and command ships. So now we have that smaller list now. So let's see if we can do a second order by. I'm not sure if we can do two order bys. Order by class. Yeah, we can. Okay, cool. So now we have ordered by class. It's by name, not by the type of, like, so for example, you might think that destroyers would come up first because they're the lowest level in this list we made here, but it's going to be by alphabetical order, and then they're ordered by the cost after that. So all the battle cruisers and the battle cruisers that meet our conditions, from highest cost to least, command ships, and then destroyers. Now let's say that we want to fine tune this even more and say and where cargo is greater than 1,000 centigrams squared, which is the unit of space for the game. So now we have a very small list of ships. So this is kind of like how you can use this to look up information. And this is kind of also how the game is going to eventually process queries in terms of the shop menu once I put in the more complex coding to allow this. Eventually, I might also add in some buttons here that will add in these operators themselves. So, like, say, like, you want to say, okay, let's say you don't know anything about coding whatsoever, and you need to know some of that for some of this stuff. So let's say you want to say, okay, I want to look for only a particular type of ship that meets this type of class value. So you say, okay, click on the where condition, and you say, okay, so class, then you click on an equals button, and it'll put an equal sign there or something. Or maybe like for some of the stuff that's more maybe not so obvious, like the whole list here, the in condition. And that's probably some stuff I ordered from Amazon. I'll get it in a second. And you can just push that and it'll put it in like that into the thing here, or like you want to add another condition or something. I don't know. Maybe I will, maybe I won't do that. It seems like maybe I'll just be cluttering this up. But I mean, it's not like I won't have some like documentation on this of what the different things are and how you can do them. So it's not like you're left on your own to do stuff. You do need to know a little bit about coding for some of this, but at the same time, it's not like you don't have to have a fifth Dan. You don't have to be a fifth Dan black belt to understand how to do some of this stuff. Now, for the advanced query browser, that's a bit different. So let's go ahead and go over here. So for this one, we're going to select a couple different tables. I might actually make this longer somehow. But we're going to select let's see, what's one that we can actually use that we have data for? So clones, clone effect, cross-reference, and effects. Alright, so this is a little more complicated. So let's actually open up the file, the database file, so I can explain this a bit better. And actually be able to make this work. Alright, so what we want to do now is we want to say we want to get we want to have a query that brings up all the clones and then the effect that clone has, or the so let's look at the clone effect. Let's look at the effects here. So we have this information here, description and whatnot. Effects that have IDs. In the clone effect cross-reference table, we have our general ID for just the table, clone ID and effect ID, and then we have our clones. So what we have to do is we have to say, okay, what do we want from these two tables? Yeah, that's what it is. Let me go grab that box real quick. I'll just leave the stream going. Joys of doing live streaming. Okay. So let's say that we want to just bring up all this information about the clones. Bring in the clones. Alright, so first we want to say, okay, from clones we want the name and let's not do the description. That'll be a huge field. I don't think I've added in the wrapping or whatever yet. But let's say we want the name. So first of all, we have to say, okay, we're going to have multiple tables, so we have to define how we have to define how to define one table from another. So how to define clones from clone effect, cross-reference from effects, and we do that using an identifier. So you can either do that or you can just call them clone. I like to use identifiers because it makes it a little bit easier to, well, it is easier and it's not easier. Like, for example, you can say clone.name, or you can say t1.name, for example. And then and then to make that make sense to the parser, you have to say then from clones as t1. So then t1 becomes an alias for the clone's table name. But you don't have to do that. I just do that. So we'll go with the way that maybe most database administrators would do this. So clones.name, clones dot class, and then clones dot t-level. Then from the effects table, we want the effect name, or is it the effect description? Effect name, yeah. So just effect name. So we'll start with the top level table. So from clones. Now on the join conditions, we're going to say inner join. So inner join. Effect on, and then now this is kind of where it gets interesting. So clones cross-reference. Sorry, this should be clone effect X reference on clones.id equals CID. Inner join effects on clone, and this is why I like to use aliases now, because when you got tables that are kind of long on the names, this kind of gets annoying to deal with. .eid, and let's see if this works. Okay, error, no such column effect.name. Effects, whoops. Typo on the equals effects.id. Make sure we got that last one in. Alright, so here we go. Now we got our clone names in here. Now let's say, okay, well, that's good and all, but I want to know what the effect modifiers are. So I want to know what this actually will do in the game. So that's when we go, okay, we need a fourth level of join here. So now we go from there, actually 5 levels, because now we do effect emod xref and then effect modifiers. So now we have to go say, okay, effect modifiers dot applies to and then effect amount. So effects.name effect modifiers dot applies to and effect. I can tell right now, database administrators would use aliases instead of doing this. This is like torturous almost. Dot effect amount. And hell, let's throw in the type 2, just to make this really long here. Effect and error prone. Dot effect amount type. Now we have the effect ID. Now we need to do an inner join on effect emod cross reference. Effect emod, and this is kind of where you need a little more knowledge with queries to do stuff, because this is a little more, well, a lot more complex than just writing a simple select statement. Effects.id equals effect emod xref dot effect id. Inner join on effect modifiers on effect emod xref dot mod id equals effect modifiers dot id. Now let's see if this works. Okay, we got a no such column effect modifiers. Oh wow, I actually have it called something entirely different than ID. That's kind of weird. That should not be like that. And here we go. So now this huge. Let's just pull this out for a second. Yeah, there's nothing important here really. Look at this. Look at the length of this freaking statement here. I'm just going to do some things here so you can kind of get an idea of what this is looking like. And this is a 4-level join here. There's 4 joins in this statement. This is kind of like insane what you want to do, but this is like what the game will have to do to be able to pull this information out when it needs to. So you have our clone, Alpha Series 1, which is a class of clone. Tech level is not there because it's not in the database. Clone 1 is the name of the effect, though you don't actually see it because we don't list the table name is not up here. We could say as clone name, do another alias here. I don't think we have to put any quotes around it. Yes, we do. Never mind that statement. It is wrong. Apparently we have to put quotes around it, which makes sense because it's really a string. You can do this. Oh, that's not the right one. You can do this, but I mean it makes it even longer. But now you see clone name, which actually is the not clone name. See clones.name. Wait, what is this name field? Now, this is where we're going to get interesting here. Oh, this is the effect name field, isn't it? That's interesting. So it moved it over. That is interesting. Why did it shift it over like that? That's kind of wow. And then we'll say as effect name. Yeah, okay, that's kind of weird though. So now you can kind of see how you can do this to make it look a little more interesting, a little more coherent, because you had 2 name fields, you didn't know what they exactly were, but this is the clone name, the class, clone class, effect name, what it applies to, so CXP, the effect amount, and what type it is. So that's like what you can do with this advanced query browser tab, is stuff like this. Stuff that would, make your brain hurt probably, usually. And then we have the database editor, which is just basically that. So we select the work mode. We have a what is this button? Well, it's a label you can click to display this little addition I made. So the work mode setting tells you how to process, tells the tool how to process your actions. So in record editing mode, you're editing an existing record. So you'll click on a record down here to load the data up here, and you can modify it, then save it, and it'll be saved into here. This is the representation of the data from the table. And then in creation mode, you'll just click on it and put in new data, then save data, and it'll show up down there. So I'll do an example of both. We'll do editing first. Whoops. So editing, and then we will choose hulls, because there's one here, basic hull. So basic hull ever. some description about it, the class, what it is basically, the tech level stuff, whatever. Let's change the durability from 360, which you can see down here, to, let's say, 500. And we'll say save data. And you can see now it's 500 durability. Let's say we want to create a new hull, though. So I'll just go ahead and change this and reload it back in. So ID we'll leave blank because we're creating a new record. So name will be second best hull ever. Wow. Forgot that. The tabbing doesn't necessarily work on this one very well because of the way the tabbing numbers are. Description, this is a test description for a ridiculously named item. Class is best hull. Best hull is the type. Tech level, we'll just say 4, power requirement 2, 4, power rate 2, 3, paramount. The only downfall is you don't really know what these specifically mean unless you have other data down here that shows you what they mean. But pair delay, durability 600. So basically, I'm creating a hull that will be self-repairing, which means it consumes power, CPU, and RAM. SG squared 45, I guess. It's like massive, but whatever. X cost 2,000, and we'll just say like 1 for the rest of this because, well, that'll be 11. Because we can, and that'll be 11 apparently. Save data, and now we have the second bestest hull ever with all this stuff in here. And that's how that tab works. So that's the modding tool. It's come a long way from where it was originally and what I started out with when I started this. Still work to do on it though for some things. But yeah, so you kind of see where this is going. I'd say this is probably about 60% completed so far. The first version of it is. This is pretty much the rest of it's going to be the Futurecast tab. But I just wanted to do a live stream real quick today to kind of just explain what's going on and to show you a little bit of the stuff that's going to be highlighted in the developers vlog on next week. I have no clue what developers vlog it actually is. I think it's 21, maybe 20 or 21. But I just wanted to kind of let you know why there haven't been any uploads and why there won't be till the week after next. And that has been accomplished, along with some other stuff. So, thanks for taking the time to watch the stream. If you're watching it after the fact, have any comments or questions, leave them below. And appreciate it if you subscribe to the channel. And I will see you next time, where I might actually this weekend do some actual streaming for Star Ocean 3, like I said I was going to do the past couple of times. Just haven't gotten around to it. I'm planning to actually do some on probably Sunday night or Monday morning, probably. Or Monday, sometime on Monday maybe, or Sunday night. One of those 2 times. Since whenever I do this and don't do uploads, I like to do streaming for other things. So, be on the lookout for that, and I will see you then.